Right, it's just before 11, so we'll get started. So last week I asked you guys to go to Sololearn, either on a desktop or use the app, which is one of the reasons why I like this website. We're looking again at Python 3. So we'll go to Learn on the Web. There we go, based, blah, blah, blah. You can see we did what last week, we covered what is Python. We did our basic first program. It's very similar to what you will have done in Small Basic way back when. We did some simple operations, and then I asked you guys to have a look at floats, and I can't get rid of that down there. Look at floats, other numerical operations, and then strings. And then today we'll recap floats. We'll go through other numerical operations. We'll do strings. We'll have a quick look at simple input and output. Then I'm going to ask you guys to finish off the first module and take the quiz this week. Again, just a reminder, this is entirely optional. So if you want to do it, great, I'll look at the work. I'll give you some feedback anytime you want. So we'll go back to floats, just because it's quite an important one. So floats, despite the name, basically means like a decimal place. So floats are used in Python to represent numbers that aren't integers. Some example, integer basically means a whole number. Well, basically, that's what it does mean. It means a whole number. So in certain circumstances, particularly with currency, for example, not everything comes out to a whole number. Some examples of numbers that are represented as floats are 0.5 and minus 7.8237591. They can be created directly by entering a number with a decimal point or by using operations such as division on integers. Extra zeros at the end, numbers end are ignored. So there's an example. We've got 3/4 is printed out as 0.75, and then it rounds up 9.8765000. The zeros are taken off the end. Computers, this is the little yellow tick box now. Computers can't store floats perfectly, accurately, in the same way that we can't write down the complete decimal expansion of a third, which would be like 0.333 recurring. Keep this in mind because it often leads to infuriating bugs. So we're going to click the green button to skip on. Which of these will not be stored as a float? So the first one is a whole number 7, which is an integer. 2/4 or 7.0, so the answer should be 7. As you saw previously, dividing any two integers produces a float. A float is also produced by running an operation on two floats or on a float and an integer. So the first one, 8/2, 8 divided by 2 gives us 4. 6 times 7 gives us 40, but here 7.0 gives us 42.0, and then 4 plus 1.65 gives us 5.65. Now moving on to the tick box, a float can be added to an integer because Python silently converts the integer to a float. However, the implicit conversion is the exception rather than the rule in Python. Usually you have to convert values manually if you want to operate on them. So fill in the blank with the output of this code. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, but with the 4.0 it should give us 15.0. Bingo. So now we've done floats, we'll have a quick look at other numerical operations that you can perform in Python. Exponentiation, I don't even say that word. Exponentiation. Besides addition, subtraction, multiplication, and division, Python also supports exponentiation. God, that was a tough word. Which is the raising of a number to the power of another. This operation is performed using 2 asterisks. So the 2 star 5 gives us 32. 9 star half gives us, so 9 times a half is 3. You can chain exponentiations to, I can't even say that word, exponentiations together. In other words, you can rise a number to the multiple powers, for example, 2, 3, 2. Let's have a quick look at the example. So here we need to have something times 2 to get 16. So we need to do 1 plus 3. So 1 plus 3 is 4. 4 times 2 is 8. Times 2 again is 16. Hopefully this is right because I did work through this earlier. There we go. Now, I'm not the best at maths, so this isn't my forte doing maths questions, but numerical operations are an important part of any programming language, so here we are. So quotient and remainder. To determine the quotient and remainder of a division, use the floor division and modulo operators respectively. Floor division is done by using 2 forward slashes. The modulo operator is carried out with a % symbol. These operators can be used with both floats or integers. This code shows that 6 goes into 20 3 times, and the remainder, 1.25, which is then divided by 0.5, is 0.25. In the example, so this is the tick box now. In the example above, 20% 6 will return 2, because 3 times 6 plus 2 is equal to 20. So 7%, and then in brackets 5/4/4/2. What is the result of this code? Is 1. So there we've had a look at other numerical operations. They're not something you'll use very much in the sort of beginning of programming in Python. The next bit though, strings, they are much more important. This is where we've done these in small basic. We will have done things like you ask someone what the weather is, and then you can join together little strings to create different outputs and stuff. So let's have a look at the strings again in Python. If you want to use text in Python, you have to use a string. A string is created by entering text between 2 single or double quotation marks. When the Python console displays a string, it generally uses single quotes. The delimiter used for a string doesn't affect how it behaves in any way. So in the example here, Python is fun in speech marks, and then the output is Python is fun in single quotation marks. Single quotation marks on the next line, always look on the bright side of life. That's from a film called The Life of Brian. And then it outputs the same thing underneath. So basically what it's showing here is if you enter it in speech marks, it will convert it into like apostrophes. The yellow box now, there is another string type in Python called docstrings that is used for block commenting, but is actually a string. You'll learn about these in future lessons if we get that far ahead. So this example, complete the code to create a string containing hello world. So we've got the speech marks in place, so we literally just need to type in world and check our answer. Well done. Strings in more detail. Some characters can't be directly included in a string. For instance, double quotes can't be directly included in double quote string. This would cause it to end prematurely. This is something that also happens in HTML. If you make a little error on what appears to be one character, you can basically ruin a whole page. So here, you can ruin a whole program if you don't check your text correctly. So characters like these must be escaped by placing a backslash before them. Other common characters that must be escaped are new lines and the backslashes. Double quotes are only needed to be escaped in double quote strings, and the same is true for single quote strings. So in the first example, basically, if you tried to put an apostrophe on Brian's, as you would do because the mother belongs to Brian, it would make a mess of it. So in the example, to make it appear visually grammatically correct for us, we use the backslash to allow us to put in the actual correct character that we would like to use. So, and also then \n represents a new line. So in the little tick box here, backslashes can also be used to escape tabs, arbitrary Unicode characters, and various other things that can't reliably be printed. These characters are known as escape characters. So one example in HTML I can give you is the and sign doesn't print right. It means something else in HTML. So if you put an and sign in, it basically doesn't work very well. You have to use a different character. You have to use a Unicode character for that one. So complete the code to complete a double quote. I think it was something like that before. I think it was that I did. There we go. So I've used \/ quote to allow us to actually show the quote. I actually thought I needed 2 quotes and then a \, but that's the correct answer. New line. So sometimes you need to push stuff down to the next line, and it isn't always easy. Same applies in old school HTML, going back for way back when. You couldn't necessarily just, if you press enter on your keyboard and you see a gap, the program doesn't always see it the same way. So sometimes you would think you've put text on a new line, but the computer would just kind of ignore the white space effectively and just go carry on. So using \n in this example will actually force, so it would say good morning customer, and then it would put on another line it would say owner, good morning sir, etc, etc. So we will go through a little example here. So go back a step, the little yellow box here. As you can see, the \n was automatically put in the output when we pressed enter. So if we want to put in, the example says first line and then second line printed as 2 lines. The code, if we don't put in \n here, it will just print it all on 1 line. So the \n forces the second line, the words second and line onto the actual second line. Again, if you want to recap any of these things, you've got the app on your phone hopefully by now, and you're quite welcome to, I will, as last week, put the video on YouTube. You can rewatch it anytime or as many times as you want. Input and output. This is something we definitely covered in Small Basic, or if not with me, with Mrs. Bonson or Mr. White. So use outputs. So this is their definition. Usually programs take an input and process it to produce an output. In Python, you can use the print function, which we've done previously, to create an output. This displays a textual representation of something on the screen. So if we do print, in the first example, print open bracket 1 + 1, because you've not put speech marks around the 1 and the 1, it sees it as an integer rather than a string, so it will just add 1. And then print, if you put with the next example, print hello world, we've used speech marks around hello world, so it treats it as a string and therefore just types whatever you type in it, outputs or prints on the screen whatever you've typed in it, and we've used \n to move the world onto the second line. And you can try it yourself if you click on this one. I mean, I'll just give you a quick example. So I could change world to say year 8, if I could actually type, and I could change this sum over here, we could change that to say 7, and then we'll run it. Hopefully it will say 8, hello year 8, there we go. So that's the example. So we've added, you can have obviously you can try any of these anytime you want in the app or on the desktop computer. When we've done this before with Small Basic, we've covered inputs and how to output things together. But this is a slightly different way of doing it, but the principle's still the same. So some of this should look fairly familiar to you guys, hopefully. So hit yellow box time again. When a string is printed, the quotes around it are not displayed. So obviously on the second line, for example, it's a string, but you don't see the speech marks or a double quote. The quotes around it, just the words we put in, which are hello and world. So question time, what is the output of this code? Print, print, print. So we've got the word print, that's when I put some output, something onto the screen. Inside we've got open brackets and a speech mark, and at the end we've got an open bracket and a speech mark. So it's going to just show us on the screen what's inside the single speech marks, which is print, print, which is this option here. I should just check it. Excellent, that one's correct. Input. To get an input from the user in Python, we can use intuitively named input function. In Small Basic, it's called input as well, I seem to remember. Things like the function prompts the user for an input and returns what they enter as a string with the contents automatically escaped. So input, enter something please, enter something please. This is what the user enters. I'll give it a quick go, just because I'm not. Let's just run this. Let's just put hello world again. It's printed hello, it says enter something please, and so we are prompted to put an input. So I typed in hello world, and it's asking us to print s, which is the variable which stores the information in the program. So the variable says input, enter something please, and then whatever the input is. So the output on the right hand side is enter something please, hello world. Let's get rid of these. No, oh, we'll leave that one. Back on here, just a little yellow box again, tip time. The print and input functions aren't very useful at the Python console, which automatically does input and output. However, they are very useful in actual programs. So how will we fill in the blank to prompt the user for an input? The answer is literally on the top line. We're going to put input. Correct. So far we have covered what is Python, your first program, simple operations, floats, which is decimal place numbers, other numerical operations, which is multiplying things very dramatically, strings, which is anything that's not a number. You can use numbers inside a string, but it would just print it as whatever number it is. It would, if you typed in as a string 11 plus 11, it would type on the screen. It would output 11 plus 11. It wouldn't say 22. And we've had a quick look at simple input and output operations. The last thing we're going to do today is string operations, 3 questions, and then I'm going to ask you guys to finish off the rest. If you want to, it's entirely optional, but the kind of task, if you will, is to finish the last 4 and then do the quiz at the end. We'll just do string operations and then I will leave you guys to it. Concatenation. As with integers and floats, strings in Python can be added together, joined together is probably a better way of saying it, using a process called concatenation. Something you can also do in Excel quite well, which can be done on any 2 strings. When concatenating strings, it doesn't matter whether they've been created with single or double quotes. So spam plus eggs equals spam eggs, because you've not added any spaces anywhere. Print first string plus comma plus second string gives first string, second string. You can at any time if you want. This network, that's not true at all. You can use this, try itself function any time and play around and see what results you get. So moving on to the little yellow tick box, you can't concatenate strings with numbers, and we'll find out why in the next lesson. So fill in the missing string. So if you notice, the first here is actually a single quote mark. So we need to do world, then finish with, well, an apostrophe really. You need to make sure that that's, if you start with a single quotation mark or an apostrophe, you need to finish with one as well. This is something I did a lot with my classes. We did error checking where I deliberately broke code and you guys were asked to fix it, looking out for things like closing brackets, capitalized letters, things like that. So there we go. So if you just typed in world, the code wouldn't work. It wouldn't recognize it as a string. It would just be like, what's this? It's just gibberish. So concatenation in a bit more detail. Even if your strings contain numbers, they are still added as strings rather than integers. Excuse me. Adding a string to a number produces an error. Even though they might look similar, they are 2 different entities. So 2 add 2 is 22 here. Because they've got the double quotation marks around it, it's treated as a string, which means it's just any character you can type. It doesn't think it's a 2. It doesn't know it's a 2. It's just a character. So if we're concatenating these 2 characters, we see 22 on screen, when 2 plus 2 obviously is 4. And this one, because we are trying to add together, excuse me, numbers and integers, so number 1 here is a number, because there's nothing around it. There's no single or double quotation marks. Now, single quotation marks on the 2 means Python will try and treat it as an integer, a string. 3 on its own is the number 3 as an integer, as a value, and then single quotation marks on the number 4 means it's treated as a string, and therefore it won't do anything. I'm not going to click on try itself because I'm pretty sure what's here is what would happen if I did try myself and then ran it. Tick box again. In future lessons, only the final line of error message will be displayed, as it is the only one that gives details about the type of error that has occurred. This isn't a bad idea, but with something we could cover in Small Basic as well, is it very often tells you what line the error is in. The traceback most recent call last thing you can kind of ignore. That's more for the people who made Python. But here it's telling you it's on line 1. So if you've got 25 lines of code, it's helpful if the program tells you which line causes the error. And that's not always the case. Certainly with things like C#, they don't always tell you what line the error is on. Let's move on. Which line of code produces an error? 3 plus 4 with no speech marks or quotation marks around any. I'm pretty sure that will work. 5 plus 6, where the 5 has got single quotation marks around it, which means it's treated as a string. And then 6, which doesn't, means it's treated as an integer. I'm pretty sure that's the one that's going to have an error. 1 plus 2, both have double quotation marks, so I'm pretty sure that will work. And then 7 plus 8, one has single quotation marks. The 8 and 7 has double quotation marks. I'm pretty sure that would also work. So my guess is this one is the one that will cause an error. So the last little bit on string operations. Strings can also be multiplied by integers. This produces a repeated version of the original string. The order, of the string and the integer doesn't matter, but the string usually comes first. Strings can't be multiplied by other strings. Strings can also cannot be multiplied by floats, even if the float is a whole number. So in the example, print spam times 3 gives us spam, spam, spam. 4 times 2, because on this example here, the 2 has a single quotation mark around it, it's treated as a string, so it'll just print 4 times whatever's inside these 2 single quotation marks, which gives us 2, 2, 2, 2, 2. 17 times 87. Now, because there are single quotation marks around both of these, that means they're both treated as strings. Like it says above, you can't, because a string is not a number in Python's head, it doesn't know what's it says. It sees a 1 and a 7, but it doesn't treat it as a number. Therefore, it can't, print 87 17 times. It just doesn't know. And the last example is just to reiterate that because here we are using 7.0, that means Python interprets that as a float, and it won't do the multiplication trick that we did in the first couple of examples. So what is the output of this code? Print 3 times 7. So because we've got single quotation marks around the 7, the answer isn't 21. You can also see by the size of the gap, it's looking for a bit of a bigger number. So the answer is 777. And there we go. So far we have covered altogether in the 2 lessons, live, broadcast, whatever. We've covered what is Python, basic introduction. We've done our first program. We've done simple operations. We've done floats. We've done other numerical operations. We've looked at strings. We've covered simple input and output, which should be very familiar based going back to small basic. String operations, which get a bit more complicated. So this week's optional task, if you want to do it, obviously either myself or Mr. White and Mrs. Bonser will give you feedback. The activity is to do type conversion, variables, in-place operators, using an editor, and then finally do the module 1 quiz. Other than that, guys, that's it from me. Feel free to send me an email or a message if you have any questions. I will put the video on YouTube very shortly, well, as soon as it lets me. I'll upload it and I'll ask Mr. White and Mrs. Bonson to share the links with you. And that's it, really. So I hope you guys are all okay. And that's it from me. Take care. Bye.